So now we're going to start talking about trigonometric ratios. So the acute angles of a right triangle can be used to identify three important ratios in math: sine, cosine, and tangent. Sine is represented as S-I-N-A and is pronounced sine even though doesn't have the E on the end. Cosine is represented by just C-O-S, A being your angle. Even though you see just C-O-S, it is cosine, not cos. Tangent is T-A-N. Again, you would pronounce this tangent, even though you just see tan, and A is your angle. Your sine for angle A is the length of the opposite side divided by the hypotenuse. Your cosine for angle A is the adjacent side divided by the hypotenuse. Your tangent for angle A is the opposite side over the adjacent side. Okay, so this just breaks it out into words. The sine of the acute angle A is the ratio created by the length of the opposite side divided by the length of the hypotenuse. And those are the same definitions that I just said a moment ago. So angles A and B are two different acute angles, so their ratios will be different. So the sine of A is the opposite side, which is side little a, divided by the hypotenuse, so A divided by C. The cosine of A, so still from angle A, is the adjacent side, which is side B, divided by the hypotenuse. And then the tangent of angle A is the opposite side divided by the adjacent side, so A over B. If I were just to do the same exact triangle, but I'm going from the opposite, or from the other acute angle, which is angle B, I would have something different. The sine of B is opposite over hypotenuse. So instead of A over C like you would have over here, it's B over C. The cosine of B is the adjacent over the hypotenuse, which is A over C. And the tangent of angle B is the opposite over the adjacent, which again they switch sides, so now it's B over A. So you might be asked to write the trigonometric ratios for the acute angles of the following triangle. So when you're asked to do this, you do not need the sine, cosine, or tangent buttons on the calculator. You just simply write the correct lengths in the correct spot in the ratios. So there's two angles, so there's going to be two sets of these. So I'm going to have a sine, cosine, and tangent of angle A, and a sine, cosine, and tangent of angle B. So for angle A, I would do opposite over hypotenuse, or 5 over 13. I can plug 5 divided by 13 in my calculator and get this decimal place. You need to get comfortable with rounding to the 4th decimal place unless told to do otherwise. The cosine of angle A is adjacent over hypotenuse, so 12 over 13, plugged into your calculator is 0.9213. Tangent is opposite over adjacent, so 5 divided by 12, or 0.4167. Once I'm done with angle A, I'm going to move up here and let angle B be the important angle. B is going to be opposite over hypotenuse, or 12 over 13. Cosine of B is adjacent over hypotenuse, which is 5 over 13. And tangent of angle B is opposite over adjacent, which is 12 over 5. So again, you're going to be asked to round to the 4 decimal places. You can actually use your calculator to divide the top number by the bottom number. And there's also something on there where I can show you how to make your calculator stop at the 4th decimal place so you don't have to do any rounding. So these are the ratios that are used to solve for missing parts of right triangles. So we have the special right triangles.
If I could have your
Pardon the interruption.
Again, a quick reminder, apparently there's quite a few cars back there. Just make sure that if you are parked in the band parking lot,
Fast forward through this.
have your car
Sorry.
moved by 4 o'clock so band can practice. Thank you so much.
So the ratios are used to solve for missing parts. When you don't have a special right triangle, we have to use the trig. So when you're given a right triangle, you ask yourself the same 2 questions every time. What do I have and what do I want? The answer should be in trig terms, like opposite, adjacent, hypotenuse, or angle. So in an example like this one, it gives you this triangle. It tells you got 39 degrees. It gives you the length of the hypotenuse is 10 centimeters, and it wants to know this leg over here. So to solve with the missing sides, you're going to ask yourself the 2 questions. They're important. What do I have? Well, I have an angle, and I have the length of the hypotenuse. What am I looking for? To this angle, I want the adjacent side. So which trig function uses hypotenuse and adjacent together? Cosine does. So you set it up by saying the cosine of my angle equals adjacent over hypotenuse. And you plug in everything that you do have. So now I need to solve for x. So to undo divided by 10, I multiply both sides by 10. And x equals 10 times the cosine of 39 degrees. This is where you're going to use that cosine button on your calculator. You're going to type in 10 times the cosine button and then 39 degrees. So what you get is 7.77 centimeters. So in our next example, I'm given a triangle and I'm told this is 71 degrees with an opposite side of 12 inches and I'm missing the adjacent side. So what do I have? I have an angle on the opposite side. What do I want? I want the adjacent side. So which trig function uses opposite and adjacent? Tangent does. So to set it up, I have my tangent of my angle, tangent of 71 degrees, equals opposite, which is 12, divided by adjacent, which is x. So when the variable is on the bottom, you actually switch the trig function in the variable. So they switch places. So to solve for x, I switch the places and I get x equals 12 divided by the tangent of 71. So when x is on top, it's a multiplication problem, and when x is on bottom, it becomes a division problem. So again, you just type in 12, the divided by sign, and tangent 71, and you get x equals 4.13 inches. So these can also be used in word problems. A surveyor is standing 50 feet from the base of a large tree. The surveyor measures the angle of elevation to the top of the tree is 71.5 degrees. How tall is the tree? Always start by drawing and labeling a right triangle. So you're going to draw the right triangle. An angle of elevation is from the ground looking up. What's the angle? And it's 71.5 degrees. It does not have to be a perfect model of the story. Just always draw a right triangle and start labeling some things. So on the ground, you're 50 feet away. So what do I have and what do I want? I have the adjacent side and an angle. And what do I want? The opposite side. So which trig function uses opposite and adjacent together? And that is tangent. So the tangent of 71.5 degrees is x divided by 50. So I'm going to solve for x by multiplying both sides times 50. And when I plug into my calculator 50 tangent 71.5, I get 149.4 feet is approximately the length or the height of the tree. Use the same steps to find the angle. What do I have and what do I want? So I'm given two sides, but I'm missing the angle. And that little, looks like a 0 with a line through the middle, is the Greek letter theta. And theta is like the x for angles. Whatever the missing angle is, we use theta instead. So I'm given my opposite and my adjacent, but I'm looking for my angle. So I plug in what I can. Tangent of theta equals 71.2 divided by 9. Well, I want to solve for theta, so I need to undo tangent. Just above the tangent button on your calculator is a tangent inverse button, or a tangent to the -1 power button. That undoes tangent. So when you undo it from one side, you undo it from the other, and you plug into your calculator that inverse button, and then the fraction 17.2 divided by 9. When you hit enter, it spits out the angle as being 62.4 degrees.